Alright guys, so remember, this is the extended topic that we were going to talk about dealing with Algebra 1 topics, and it's compounded inequalities. So if you remember on Friday after your quiz, I gave you this to kind of look at. All of these are examples of compound inequalities. So we're going to come back to this sheet, but if you grab your note sheet for today, let's talk about what compound inequalities are, how to solve them, how to determine what they are. So, and again, remember this is an Algebra 1 topic, so it's okay if you're struggling a little bit. This is just to give you some looks into it. Remember, you're actually only in 7th grade math, so seeing this is huge for you guys. So what a compound inequality is it's an inequality, okay, an inequality formed by two inequalities put together. So we've been working with just one inequality. This is putting two of them together, and how we put them together is with either the words and or the words or. Okay? So there's a huge difference between the two. So how I think of it is if you're at the grocery store and your mom tells you you can have a Snickers and a Twix, what does that mean? It means you get to have both. So it means you get to have both candy bars and eat them both and enjoy them both. Okay, so it actually, you can do both. If you're at the grocery store and your mom says you can have a Snickers or a Twix, unfortunately that means you can have one or the other. You can't do both. You can have one or the other. Well, the same holds true for inequalities. The and inequalities, okay, what the and inequalities are is our value satisfies both. So our answer satisfies both inequalities. Okay? So and means you can do both at the same time. You can have them both, you can do them both. It's like that candy bar. You can have a Snickers and Twix. We can get them both. The or, which I'm going to use green for all today, or means you have one or the other. You can't do both. Okay? So how those will look, if you notice, let me grab another highlighter quick. Sorry. If we look at this, the and one, our example is x is greater than or equal to 2, would show like this, and x is less than 5. Okay? So if we look at those, we can pick a value that satisfies both. If I need a number that's bigger than 2 but less than 5, we can do that. 3 would work, 4 would work, 2 would work, 2.5 would work. There's numbers that work. So if you look, they overlap. So an and one is when it falls in between some numbers. We can get a value that satisfies both. Like I said, 3 satisfies both these inequalities. So we can put them together with the word and because x falls in between them, our values that are correct fall in between, we can actually write it out as one whole inequality with our x in between, because x falls in between. Now, or if we look at it, my first inequality is y is less than or equal to negative 2. So if I graph that, it would look like this. And then my other one, or y is greater than 1. Is there any value in the world that could satisfy both? No. So this is one that's or, because I can either be this or be that. I can't do both. So when we graph it, it literally just looks like two different inequalities on a graph. And it's or because, again, I can only be in one side or the other. There is no way to be in both. So that's the difference between and or inequalities. One looks like a number or inequality is just in between. The other has two different inequalities on it. So if we're looking at an example on how to write it, okay, when you're reading it, we have a number x is greater than 8. Sorry, x is greater than negative 8. And, being our keyword, less than or equal to 4. So, if we think about this, the and means we can satisfy both. We can find some number that is greater than negative 8 and less than equal or equal to 4, right? Any number in between them is going to work. So, when we're writing it, there's two ways you can write it. You can write it out as two different inequalities, which is probably the easiest, so we'll start with this. x is greater than negative 8. So I'd start with x is greater than negative 8. And, so we can write that word, less than or equal to 4. Well, we're still talking about the number x, so then I'd say x is less than or equal to negative 4. That's the first way to do it, and probably the easiest way to do it. But eventually we want to get you to be able to write it as one whole inequality when they're ands. To do this, I find it easier to then graph and then come up with the inequality. So if I'm doing this, make my number line. Okay, I know I need, oh, this isn't supposed to be negative 4. Sorry, less than or equal to 4. So we're going between negative 8 and 4. I'm going to count up by 2's on my number line just because it's easier. So I'm going to start at 0, 2, 4, 6, 8, go backwards, negative 2, negative 4, negative 6, negative 8, and we'll go to negative 10. Why not? And 10. Okay, so there's my number line. I know x is going to be bigger than negative 8. So if I were to draw this, I would start at negative 8. It would be an open circle because it's not equal to. And anything bigger than negative 8 would be negative 6, 0. So I know it's going to go in this direction. But then I have that other stipulation. It has to be less than or equal to 4. So I'd have a dot. So while this can go here, we have to stop here. So it's going to connect from here to here because less than 4. So it's falling between those because it has to be both. So that would be my answer. This, I feel like graphing it first and then coming up with the inequality is easier because then I know my starting point is negative 8 and I know I'm going to go to 4. I know x falls in between them because remember this line represents all possible x values. And then I know x is bigger than 8 and less than and equal to 4. Both of these would be considered correct. You can write it either way, but that is how you do it. Okay? So again, on this one, if we have a number y is at most 0. Remember, at most means like if I said you could have at most 3 dogs. Means you can have 3 dogs, 2 dogs, 1 dog, 0 dogs. Technically negative dogs. That's a bad example, but it's anything less than 0. And then it says, or at least 2. If I told you you could have at least 2 candy bars, that means you can have 2 or more. So this means 2 or more. So if we're writing this, again, I'm going to graph it first because I find it easier to graph first and then come up with the inequality. I know I need 0, 1, 2, 3, 4. Oops. I think I screwed this up when I explained it to you guys. But we'll just keep writing. Oh yeah, no I didn't. This is less than 0 and 2 or more. If we're looking at this, it's an or, because can we actually satisfy less than 0 and more than 2 at the same time? No, there's no number that exists. So, if we're going to graph this, I'm going to start at 0, and it can't be 0, so it's going to go that way. Okay? And then at least 2 would go this way. So an or is separated by those 2, and is here. The huge difference, and I can find a value that satisfies both of these, or I can't. With or, we can only write it one way. We can say x is, oh sorry, we're not doing x. What number did they tell us it is? Y. So it'd be y is less than 0, or, we need to write the word or, y is greater than or equal to 2. Okay, so that's how you would do this. Okay. All right, I'm going to give you time to, I'm going to pause this video, give you time to do numbers 1 and 2 on your own.